In this problem, we need the sample size that is needed to estimate a percentage, which is the same thing as a proportion. So when you're doing these sample size problems, first thing you want to ask yourself is this about a mean or is it about a proportion? If it's about a mean, then you're going to use the formula n is approximately equal to z sub alpha over 2 times sigma divided by the margin of error. You take that whole quantity and you square it. If it's about a proportion, let's move that over. Okay. Then there's two possibilities. Either you have an estimate of P, or you have no estimate. If you have an estimate of P, then n is going to be approximately equal to that estimate of P times 1 minus the estimate of P, and then we multiply that by the quantity z sub alpha over 2 divided by the margin of error squared. If there's no estimate, we're really using the same formula can't do that on a chalkboard. Okay, but I take out that P times 1 minus P. What we're going to assume is that our estimate of P is 0.5. And so 1 minus P is also 0.5. You multiply those together and you get 0.25. So our formula when there's no estimate for P is that n is approximately equal to 0.25 times the quantity z sub alpha over 2 divided by the margin of error squared. So this is the scenario that we have for this problem. There's no estimate for P. So that's the formula we'll use. And let's get rid of everything. Okay, so we're ready to start our problem. And our formula is n is approximately equal to 0.25 times z sub alpha over 2 divided by that margin of error. And we square this. They use a slightly different format for this formula in the book, and it's much more complicated to calculate. So this is what we're going to use. Our confidence level is 90%. So off to the side here, I'm going to find 90% in the center. And my question is, what is this z sub alpha over 2? So alpha, if we have 90% in the center, alpha is 10%. That means I have 5% in the tail. That's where I cut alpha in half. So I'm finding z sub 0.05. And I can do that in the calculator by finding inverse norm 0.05, 0, 1. And that gives me 1.64. And I actually cheated because it's really 1 minus 0.05. But if you just do inverse norm of 0.05, it'll give you negative 1.64. And honestly, it doesn't matter because you're going to square it anyhow. So n is approximately equal to 0.25. We've got 1.64 in the numerator of our fraction. The margin of error is 0.05. That goes in the denominator of the fraction. And we square that fraction, multiply by 0.25, and I get what? 268.96. Now, in these cases, we're looking for the number in the sample size. It has to be a whole number. So we're always going to go up because we'd rather go up to the next higher number. If you round down, then you're not going to quite have the confidence level you need or the margin of error. So we're going to make this into 269, and that's my final answer. But even if it had been 268.001, I still would have said 269 was the answer. So just keep that in mind. We always go up to the next higher one, only in these sample size problems. That's the only time that happens. So 269, final answer.